Hi again and welcome to the last module of the Advanced Record Linkage course. Today I hope we will have the most rewarding session because we are going to learn how to build a user-friendly record linkage tool. Finally, okay, something that doesn't require much coding, at least from the user experience point of view. Okay, let's get started. Once again, we are going to use Google Collaboratory Notebooks. Remember, we have this folder. Today we are going to be using the data that is embedded within this module for example folder. Let's create our Google Collaboratory Notebook. I'm going to call it Module 4, Record Linkage Advanced Example for Consistency. Okay. So the objective of today is to build a notebook that other users can interact with without much problem. So what's important when you want to do that is that we document the notebooks a little bit better than we used to do. Okay, so you can see here in the notebook that we can add code and text. Code is what we have been doing most of the time, essentially putting code and then running it, but we can also put comments on the notebook by clicking here on text. So for instance, we might want to put a title that says my first record linkage tool. Okay, and we can even put a small definition of what's going to happen here. This simple tool does supervised machine learning for record linkage without the need of writing a single line of code. Just follow the instructions below. Okay? Very good. So you can see that this now appears here in a nice format. So we want to hide code from users because users typically get scared of seeing code, and this can be very nicely done with a Google Collaboratory by clicking here and adding a form. Okay, so a form is simply a code that Google interprets in a user-friendly way. Yeah. So for instance, we can put a title here that says install dependencies. Yeah, and I'm putting here this command. This is called the magic command, that what it's going to do is it's going to capture all the output of whatever we run here so that it doesn't get dirty. Okay, remember that before we had all the progress of the installation. We don't want to see that anymore, so we just capture that in the background. Okay, so now we just have to run the code that we want for this particular instruction, which is installing dependencies. We might want to add some comments here on top of that, like you can add more lines of comments like this. Markdown, click play. Markdown is when you want to add just plain text. Okay, click play to install the Ester linkage package from GitHub. Okay, so this is going to install our Ester linkage package that we have in GitHub. So remember, this was the instruction that we can use to install this package. Pip install github.com erciliaos esterlinkage.git, and then we will import the modules that we will use eventually downstream here. Okay, we can use this cell to import the modules that we will use eventually here. So once we have written the code, we can hide the form, the code, and what we are going to display is something like this, and we can run it. Okay, so now we can write another chunk of code as a form that we are going to use to upload the source file. Before, if you remember, we had to mount Google Drive and it might have been a little bit difficult. So really here what we want to do is to make life easy for our users. So for instance, we can write this form, and we are encouraging the user to upload a source file called source CSV. And this can be done with collab with these instructions. Yeah, files.upload, and then reading whatever we upload as a CSV file. Okay, so if we click here, we can hide the code if we want now. It's going to ask for a source file. I'm going to choose it from our module, for example, the source file. And it's uploaded and it's already read. Yeah. So this is how the source file looks like. Have a client ID, first name, surname, sex, date of birth, date of visit, and a clinical variable. All of the columns are in capital letters. Okay. Now let's maybe upload the target file. So in this case, again, I'm creating a form, and I'm mirroring the previous syntax for uploading a target file. Okay, files upload, I read it as a CSV, and the file is going to be called target.csv. So again, I can hide the code here and run it. So now it's asking for my target file, which I have here. And it's uploaded. You can see that the source file was already quite big, 1000 rows. This target file has 5000 rows. So relatively big files we are dealing with here. This is really a realistic case scenario, okay? Let's now focus on the ground truth. For the ground truth, you can add a form. And I'm uploading the truth that we have in our folder. Remember, I just want to sample a few cases here, so maybe I'm going to sample 250. Okay, I'm going to sample only 250 of the ground truth that I'm providing, which is much bigger. The reason for this is because I want to make it this case look as real as possible. So having a few hundred labeled labeled records seems realistic to me. So I'm uploading the ground truth here and storing it as a df gold, choosing the file, truth, very good, and let me hide the code. Okay, so we have the source file already, we have the target file already, and we have the ground truth already, and no code is visible to the user. Okay, so now let's go let's make a form so that users can specify the matching scheme, okay, which remember will require some manual edits because the column names here do not correspond to the column names here. For this, we can do it as follows. We add a form that we can entitle match columns manually. We can add some comments so that life becomes easier for the user. Okay, and then all what we want to do to keep in a variable the fields that the user is filling in. Okay, So this can be done like this with this param instruction in Python, and the type of data that we are reading here is a string. Yeah. So the identifier, we will ask the user to fill this in. Okay, the first name, we will ask the user to fill this in. Same with the last name. Same with the sex, and same with the birth date, and same with the visit date. Okay, so let's hide the code for a moment. Hide code. So and let's check what did we have as first name, surname in this source file. First name, surname, sex, date of birth, date of visit, okay, and client ID. So this is precisely what we want to fill in here to make it work. Client ID, first name, surname, sex, date of birth, and date of visit. Okay, so those are the columns in the source file, those are the columns in the target file. If we unhide this, you can see that Colab has been smart enough to update this in the code correspondingly. Okay, so this is quite convenient. Very good. Now, once we have this, we can define our dictionary as we used to do. And this dictionary can look like this, where identifier is the value that we've put here, so client ID. And the first name is the value that we've put here. Last name, sex, birth date, and visit date are the values that we've put here correspondingly. Okay. Remember, this was an input that we needed to start our record linkage pipeline. Okay. So let me hide the code again and run this. Very good. So now we have already a mapping that will help us start with the end-to-end record linkage pipeline. So this is what we want to do in the next step. I'm adding a form. And we add a bit of enthusiasm here because this is the most important step of the pipeline. Okay. So for this, remember, we had a function in our helper repository, the Esther linkage repository, that was called end-to-end pipeline. Yeah, remember, this function can be found inside this repository in here at the end of this script. Yeah, this script is what we built in the previous session. We built all of these functions in the previous session. I've just put them here for convenience. Okay, so I'm importing this function from that script, and I'm putting as input the source file that we have just uploaded, the target file that we have just uploaded, the gold standard data set, and the columns that we have just defined. Okay, and then I'm running this. It seemed to run well, so let me run it and display the data frame already. Okay, so here I'm going to hide the code, and we can see the results. We can see the results here. Yes, so the algorithm seems to do what it's supposed to do, because innocent piri corresponds to innocent piri. Vivian Muamba corresponds to Vivian Muamba, Tamara to Tamara, John Muanza to John Muanza, etc. Okay, so the linkage worked well. All what remains now is to download the data. So this can be done again by creating a form. Where we are saving as a CSV file our results data frame. We save it to a file called linkage.csv. And we instruct Google Colab to download this file to our local computer. Okay, so let me hide the code here. So when we run this, the file is downloading and is downloaded in my local computer. Very good. I think this is all I wanted to show to you today. As you can see, now we have a very neat software here that people can use to run record linkage without the need of having a lot of Python expertise, okay, because they are not exposed to the code. Okay, this is all I wanted to show to you today. I hope you will be able to build a tool like this one that satisfies your needs in your local institutions. Thank you all, and see you next time.